Hello, this is Screencast assignment number 1 for CIS 305. My name is Brian Lugo. Today we're going to be talking about different database concepts such as entities, attributes, business rules, and relationship types. An entity is a data object we want to capture and put in a database. It can be a real-world object. For instance, we can have a database that has an entity of a school, teacher, class, or courses. And entities are usually noted by a rectangular shape, such as the one right here, course. An entity type is a fundamental building block for describing the structure of the data, and it usually represents the top level concepts. For instance, a student could be an entity type in which all these different students share many different common characteristics. The entity instance is a single occurrence of an entity type. For instance, the entity instance Brian Lugo, which is me, is a entity instance of student, which once again, entity instance is a single occurrence of the entity type. And a weak entity is an entity that cannot survive without a strong entity. It is wholly dependent and cannot exist in and of itself without it, usually noted by the double bar here. An example of a weak entity would be the classroom that we're usually in, classroom 220, cannot exist without the strong entity, building 163. Attributes are usually a property or characteristic, which means that it is a characteristic of an entity. For instance, an example that might be the color of somebody's hair or the color of your eyes, and the entity stores the piece of data about the object it's representing. Another example is that if we have an invoice and we are trying to name the attributes, we might name a price, phone number, date, or if it's paid or unpaid as different types of attributes for that particular characteristic. Another one to go over is a required attribute. And in order for something to be an required attribute, there must be a certain value for it. In other words, that field cannot be left empty. As noted here, it says, please do not leave out this field. And the reason that there must be a required attribute is because there needs to be some sort of reference point for, like for instance, on an entity for it to be taken to. Like for here, we have student, last name and first name are the required attributes of student. Without it, there would be no student table to reference back to, whereas the initial middle name, email, or phone number can be optional attributes because there are instances where student may not have a phone or an email. Next, we also have a composite attribute, which is made up of more than one simple attribute. So if we were to have an attribute name, it is made up of, say, the first name and the last name of that student. Another example of this may be an address where it has a zip code, street number, state, city. So there are more than one different attributes that we can attribute to that. There's also an identifier, which is an attribute of an entity that is wholly unique. For instance, CD is the unique identifier for this table right here, and it's usually noted by a solid underline, and it usually designates the instance of an entity that is being dealt with. And it's important to know that the value of the identifier will not change for the lifetime of that instance. Something that's also important is a multi-valued attribute, and what that is that there may be certain instances where an attribute may have more than one value. For an example, if you were to have the contact number of a student, there may be more than one or two numbers associated with it. So a student might have a home phone number or a work phone number or their home phone number. So sometimes attributes can have more than one value. The derived attribute is something that may not exactly exist in a database. It could be something, for instance, that is derived from other pieces of data. Let's look right here, for instance. Age may not be something that we manually input into the database, but it can be derived from the fact that we know the date of birth of the student as well as the day of the current day as well, and that can be derived from a simple algorithm. So age may not be something that needs to be inputted, but can be basically summed up. The business rules are statements that describe a business policy or procedure. They're usually derived from the different functions, events, or happenstance of a company. So it is also important to note that they are usually declarative, which means that they say what they are, not how they are. Precise, give a clear meaning. Atomic, which means that they can't be broken down any further. Consistent, which means that it is both consistent internally and internally. So for instance, a business rule here may be that we have a programmer who makes cool stuff. So the business rule here is that he makes things. Also, we have different relationship types. A relationship type is a meaningful association between different entities. For instance, in the relationship between employee and course is that there is something that's being completed. So an employee can complete many courses, and a course can be completed by many different employees. And a relationship instance is the link between the entities, and where each relationship instance associates exactly one entity instance for each particular entity type. For instance, we have employees that work for a department, and from E1 to D1 would be considered a relationship instance, whereas E2 to D2 here would be considered another relationship instance. We also have various degrees of relationships, and what that simply denotes is that it's supposed to say the different number of entities that are participating in a type of relationship. For instance, beginning with unitary relationship, we have what is considered a one-to-one relationship. So one person may be married to another person, or for instance, the next one, an employee may manage other employees. So once again, that is one type of entity being related to another, or an entity of the exact same type. Whereas a binary relationship usually deals with two different types of entities relating to each other. For instance, we have the entity of department relating with the entity of employee, and that means that there's two degrees. And a ternary relationship means that there are three different relationships between three different types of entities. Cardinality constraints have to deal with the different types of instances one entity can be associated with another entity. For instance, it could be a one-to-one relationship, a one-to-many, or a many-to-many relationship. Or maybe a mandatory one, which is denoted by double bars, mandatory many, which is the claw, optional one, which is the open circle with the bar, or optional many, which is the circle with the claw on it. The minimum cardinality simply means that there is an instance where one entity may be associated with the instance of another, which basically means that there's an optionality with regard to a relationship with another thing. For instance, there may be an instance where A may not need an occurrence of B, and that is noted by the circle, or the one, which is simply the one line here, which means that there needs to be at least one occurrence of B, in this relationship. It cannot be like the one above it where there was no occurrences. There needs to be at least minimum one. Maximum cardinality simply means that there's a number of elements in a set is always one or many, and that the maximum number of instances for the entity may be associated with a single occurrence of another entity. So again, if we were to look here, we would notice that B to A, there needs to be a maximum of one instances occurring between the two, whereas on the bottom one, we see that B to A, there can be many number of instances between the two relationships. And last, we have an associative entity, which is an entity that associates the instances of one or more entity type and contains attributes that are particular to the relationship between those instances. For instance, there can be many-to-many relationships which unfortunately cannot exist and need to be resolved, and that is where the associative entity comes in. For instance, we see here that assignment is being brought in order to break up the many-to-many relationship of employees and projects. So now that this type of entity is being brought in, the many-to-many relationship can be resolved, and we have a one-to-many relationship from employee to assignment and a one-to-many relationship from project to assignment, as opposed to a many-many relationship between the employees and the project. I'd like to thank you for watching and have a great day.